But we do have Rebecca Thompson here, who's going to share our virtual chemistry class tonight. And I mean, I've spoken with her already. She seems like a fantastic person. Um, and I'm really interested to see how this goes. And I mean, it looks good. So I'm very, very grateful for everyone who has registered to attend tonight. And I'm going to stop talking now and hand it over to Rebecca. So thank you.
Okay. Hi, everybody. As Jess said, I'm Rebecca, and I have been in the pool industry for 20 plus years. And in that 20 plus years, I have done nothing but chemicals. I always tell people I think I look pretty good for doing chemicals for 20 years. I am going to do a water chemistry class. Hopefully I can make it fun and not boring, because I do know that chemistry isn't as exciting to everyone as it is to me. My teachers in school would have said I wasn't, but I do think that I'm a little bit of a chemical geek. I'm going to go over water balance and the importance of water balance, sanitizing, oxidizing, accessories, water testing, and common problems at the end. If you have any questions, type them in. For some reason, I'm not able to see the questions, so Jess might jump in with a question, but if not, I'll see them all in the Q&A afterwards. What is water balance and why is it important? Water balance consists of total alkalinity, pH, calcium hardness, total dissolved solids, metals, such as copper, iron, and manganese are the most commonly found, copper and iron being the most common. And why is it important? Improper water balance can cause staining, corrosion, eye and skin irritation to the swimmers, and it can affect your water clarity. It can make your sanitizer ineffective, which can cause algae growth and green pools, which none of us want to see. Total alkalinity. Alkalinity is the measure of water's ability to resist pH change. I start with total alkalinity because total alkalinity should be the item that is adjusted first. Years ago, there was a product manufactured by Church and Dwight that was called alkalinity first. The reason you would adjust your alkalinity first is that it is the buffer. It keeps your pH in range where it should be, and it prevents pH bounce. The ideal range for chlorine pools is 80 to 120 parts per million. And I know that different companies have adjusted that. I have seen the ideal range for total alkalinity being all the way up to 180 to 200 and as low to 50 parts per million. When I got in the pool industry, it was 80 to 120, and that's what I've stuck with because that's what I've seen for 20 plus years. Problems if your alkalinity gets outside of the range, too low can cause pH bounce. It can cause etching of the pool surface, especially on gunite or calcium pools, or concrete, gunite or concrete pools. It can cause staining because it'll allow your metals to fall out of sequestering and cause staining. It can cause heater failure because it affects the heater core, eye and skin irritation, and your sanitizer dissipates much more rapidly. Too high can, again, cause pH bounce. Too high of total alkalinity can cause cloudy water. One of the reasons it causes cloudy water is the pH going up and down. And also it can cause calcium in the water to fall out of consistency. Again, it can cause etching or scaling, which can lead to rough pool surfaces, and clogged filters, heater elements, and it can reduce your circulation with clogging the filter. One thing that we need to remember is high cyanuric acid can affect your total alkalinity reading. If you have a total alkalinity reading of, say, 80 parts per million, and your cyanuric acid reading of 120 parts per million, well, you would take 1/3 of your cyanuric acid reading, which would be 40, and subtract that from your cyanuric acid, or I'm sorry, from your total alkalinity reading. So if you take your total alkalinity reading of 80 and you subtract the 40, you have a adjusted total alkalinity reading of 40 parts per million, which the 80 parts per million that you got when doing the test is within range, a little on the low side, but it's within range. But when you adjust it due to high cyanuric acid, that gives you a 40, which is way too low. So you need to keep that in mind when you are looking at your total alkalinity. And I will discuss cyanuric acid too. Water balance and pH. pH is most has the most impact on properly balanced water. It's the measure of how acidic or basic the water is. The ideal range is 7.2 to 7.6. One of the reasons, the pH of your eyes is 7.4. The pH of blood is 7.4. Anything outside of that 7.2 to 7.6 range can lead to eye irritation for the swimmer. And we all know when we've got kids in the pool, we don't want them coming out with red eyes. I've heard over and over, oh, the chlorine burns my kids' eyes. Well, the chlorine does affect the pH, but truthfully, it's the pH that's burning your kids' eyes. People that say, well, I'm allergic to chlorine. Then what do you drink? Because the majority of your water, if you live in the city, has chlorine in it. So it's, again, the pH irritating the skin, which can cause, the swimmers to think that they're allergic to pH, or I'm sorry, allergic to chlorine, when, as I said, it's the pH affecting your skin. Low pH, again, can cause corrosive water. With the corrosive water, again, you end up with the etching of the pool surface, and, corrosion of metals, and other issues that go on. Other problems can cause your low pH causes chlorine loss. What it does is it makes your chlorine more effective, and it burns off quicker. It can cause wrinkles in vinyl liners, and it can, as I said, cause skin and eye irritation. One of the things that I've always told dealers is keep track of your customers' water balance. If they're constantly running a low pH and then they come in and want you to pay for their liner because you had to install it wrong because it's wrinkled, and they have constantly had a low pH, that could be the issue and why their liner is wrinkled. A lot of your heater manufacturers will ask for water balance before they determine whether or not they're going to pay a warranty. Again, a pH out of range can cause your problems with your heater core. And if the consumer has constantly kept their pH either too high or too low, then it's not the heater manufacturer's problem that their heater has gone out. Too high pH, again, can cause clogged filters, heater elements. It can reduce the circulation due to the clogged filters. Cloudy water, again, calcium issues. Other problems are your chlorine is ineffective. The higher your pH, the less that your tabs are going to dissolve, and it's going to make your chlorine less effective because it's not got the kill ratio. And again, too high is eye and skin irritation. Water balance and calcium hardness. One of the issues we have is with calcium hardness is sometimes if somebody wants their calcium hardness to be between 2 and 400, which is the ideal range, what does it come out of the tap? So what you want to do is if your calcium hardness comes out of the tap at 400 or above, you don't want to do anything that's going to add calcium to that pool. Calcium hardness is the measurement of calcium carbonate content of the water, and that's dissolved calcium in the water. Most of the time, city water, it's not that high. A lot of the times, well water, it is. I know with traveling a lot, different areas of the country have higher calcium in their water than other areas. In, say, Michigan, they have a high calcium due to minerals in the ground. In Indiana, northern Indiana, we have low calcium. High Indiana, or lower, the southern part of the state has high calcium because of limestone and bedrock in the ground. So knowing what your calcium comes out of the tap at will help you when adjusting your customer's water balance. Same way with pH and alkalinity if they're on city water. Too low corrosive water. It can cause etching, staining of the surface, heater failure. Too low calcium in a hot tub can cause your water to be foamy. When we use our water in our house, a lot of people have water softeners. And what that does is it takes the calcium out of the water to make it softer. Well, what does that do? It allows your dish soap and your laundry soap to foam better, which gives it a better cleaning. So if your calcium is too low, you can end up with foaming in, I say a hot tub usually because you have the aeration, which is moving the water around, but you can also get it into a pool, especially if you've got somebody getting in with a swimsuit that has not been rinsed twice, or somebody that uses a lot of soaps and lotions that can cause foaming. Then you can end up with foam due to low calcium readings. When I have somebody call me about a spa or hot tub foaming, that's typically the first thing I ask is, what's your calcium hardness? And calcium hardness isn't something that everybody tests every time they test water. It's not really something, because once it's in there, unless you're using a calcium hypochlorite shock, you're not increasing your calcium typically. So it's not something that you need to test all the time. But if you have issues, it is something that's pretty important to test. Too high of calcium, again, can cause scaling. You'll get a calcium buildup on the pool or even on the deck around the pool. A lot of the times you'll see a buildup if you have waterfalls. You'll see a scaling buildup on the waterfalls, which is the rough pool surfaces. If you've been to Florida on vacation and you've been in a pool, at any pool outdoors, a lot of the times those have low calcium, and you can feel the etching on the bottom. One of the things with calcium is your pool is going to suck the calcium out of the water to equalize itself. And so it's very important to maintain a calcium hardness reading within the 2 to 400 range. Water balance and total dissolved solids. Total dissolved solids is the measure of the total of the soluble substances that are dissolved in the water. It's measured by electrical conductivity of the pool water. The ideal range is 0 to 2,500 or 1,500 over your fill water. Again, knowing what the total dissolved solids of the fill water is very important, especially out west. Arizona will have total dissolved solids coming out of the ground at 2,500 parts per million. So that's why we've gone to the 1,500 over the fill water if you come out above that or higher than that range. Sorry for the misspelled salt there. Salt pools is 0 to 2,500 plus 3,000 to 3,500 parts per million. And the reason is your salt in there is going to dissolve and increase your TDS, but what you're reading there is the salt. One thing that's very important is to know what your customer is on. I heard a story about a guy who went in and had a salt pool, went in, had his water tested at a dealer that he didn't normally go to. So this dealer did not know he was on salt and told him that his total dissolved solids were too high and he needed to drain and refill. When he went back to his dealer, the dealer said, you have no salt in your pool, so you have to add salt. Of course, the customer was upset because he had just dumped the salt out into his yard. Total dissolved solids, too low, there's no issues. Too high, the sanitizer is ineffective. Cloudy water, staining, and scaling. If you'll notice, you have a lot of staining and scaling in cloudy water if things are out of range. The best way to discuss total dissolved solids with your customers, if they're like, I don't understand total dissolved solids and how is that affecting my water balance, take a glass of iced tea and put a spoonful of sugar in it. You stir it, it dissolves. Put another spoonful of sugar in it, you stir it, it dissolves again. The more sugar you put in it, the less it's going to dissolve, where you get to a point where the sugar stops dissolving and it's sitting on the bottom of your glass. There you have reached your maximum total dissolved solids of that glass of tea where nothing is dissolving, which leads to your chemicals, your sanitizer being ineffective, because if it's not dissolving, it's not killing. And so that's the best way that I have found to describe that to consumers. It puts it in terms that make it a little easier to understand. And that way they can see, yeah, okay, you put sugar in a glass of tea and after time it does quit dissolving. Sanitizers. This is a point where I get kind of geeky, but I try to make it easy enough for everybody to understand. Your EPA registered sanitizers are chlorine gas, which we don't see very much anymore. Liquid chlorine, some people refer to it as bleach. There is a difference in bleach and chlorine. Bleach is manufactured at about 3 parts per million of effective chlorine. Liquid chlorine is manufactured at 16, so that when you're selling it, it's somewhere around 12 parts per million. Calcium hypochloride, cal hypo, lithium hypochloride. If you can find it anymore, you're very lucky. There is one manufacturer of lithium hypochloride, and they decided they can make more money off of batteries. So it's very difficult to find lithium in the pool industry. Dichlor, trichlor, which we're all pretty much used to. And, those are dirty words this year because this year there will be a shortage of those products. Bromine is also an EPA registered sanitizer. If you can remember back to chemistry class, you had the periodic table to look at. And in your periodic table, you had iodine, and then you had chlorine and bromine set right underneath it in the table. And then we also have biguanides, PHMB as an EPA registered sanitizer. and then chlorine generators, which what you're producing with the chlorine generator is liquid chlorine, otherwise called a saltwater pool. Helpers, which are not currently registered with the EPA as a sanitizer, consist of ozone, UV or ultraviolet, ionizers, and then pristine blue. These products kill, but like with UV, it's only killing when the water passes through the UV system. So that's the only time when it's killing. And as we all know, every bit of water in that pool does not pass through your filter system. So that's one thing. Ionizers is another form of metal. At this time, metals with ionizers and pristine blue, they are considered bactericides or algicides, in that they don't have a fast enough kill ratio to be listed as or be registered as a sanitizer. Chlorine comparison. This is one of the things that I try and talk about a little bit because it is important, is knowing the pH and the available chlorine of the product that you're using. Chlorine gas, which I said, we don't see a lot of, has an available chlorine of 100 parts per million, and a pH of 2 to 4, which is very, very low. Liquid chlorine is typically 10 to 15 parts per million of available chlorine. And the average pH of that is about 12.6. I've seen it as high as 13 or 14 parts per million of your pH. Solid or granular available chlorine, a lot of the time, is 65 to 75% available chlorine, with a pH, or I'm sorry, Cal Hypo comes as a solid or granular, with a pH of 11.5. Again, a very high pH. Trichlor, which is a solid, typically has a pH of 3 to 3.5 with a available chlorine of 90%. Dichlor, which is a granular, available chlorines typically are 55 to 62%. There are some on the market that are 99% available chlorine, and it typically has a more neutral pH of 6 to 7. One of the reasons I like to let everybody know the pH of the product that they're using is you can use your chlorine to help balance the water. If your customer has a high pH and you are shocking them with liquid chlorine, all that's going to do is cause their pH to drive up higher. So you need to consider that. As I said, with a salt system, you're manufacturing liquid chlorine, sodium hypochlorite. So again, those have a tendency to have a higher pH. So that's important to know when you're looking at balancing your customer's water. On the salt system, you're going to want to make sure that they monitor that pH and keep it low. If they're using liquid chlorine, the same thing. With pools that have an auto cover on them, a lot of the times I'm hearing complaints that screws and on the face plates are rusting, and that is caused by the high pH. Well, if you've got that auto cover closed, the only place for the chlorine to gas off is through the little tiny hole in the cover on your skimmer. So that's like the water going out through a chimney. So all of that, the gas is going out through the chimney. So all of that gas is going out through that one little hole. So with your auto cover on, or even a solar blanket, it's pushing everything out that hole. So all of that high pH is running right past all of those screws that are are on your skimmer basket, which can lead to the rusting that we're seeing in the plates on your skimmer. One thing to look at when customers are complaining about that is, do they open their cover to let their pool breathe? And do they keep their cover on all the time with just that little tiny, as I call it, chimney for the water to come out? Chlorine, we have stabilized and unstabilized. Your solid chlorines and your granular chlorines are stabilized. They use cyanuric acid to hold those products together. Your liquid chlorine and your gas chlorines are unstabilized. So if you're using liquid chlorine or a salt system and you have no stabilizer or no cyanuric acid in that pool, then you will burn off your chlorine very quickly. If we hit 100 degrees, you have no chlorine in that pool whatsoever. The ideal range of free available chlorine in a pool is between 1 and 3 parts per million. 1 part per million of chlorine in a pool is killing. And this is determined by your health department. Sometimes they have different ranges. Trichlor. Trichlor is something that we're using quite frequently. As I said, it's 90% available chlorine, pH of 2.9. It is slow dissolving. It is the strong form of chlorine available at 90%. It does dissolve completely. It does not cloud the water typically. And being that it is stabilized, it does not dissipate due to the sun. As I said, I'm a geek at times. That is the molecule of trichlor. Dichlor, again, it's 55 to 60% available chlorine. I have seen it up to 99% available chlorine. And it comes in a granular form. One of the issues with dichlor is getting it to dissolve. If you're throwing it in the pool, you want to make sure it dissolves. If it doesn't dissolve, it's going to cause bleaching of the liner. And we don't need that, because then your customer is going to be complaining that their liner is bleached out. Dichlor will dissolve but the water has to be above 70 degrees. Typically on the packaging, it says to dissolve prior to adding to the pool. This is because it doesn't dissolve quickly, and it can lead to the bleaching of liners. And again, this is the molecule of dichlor. If you'll notice on the trichlor, there are 3 chlorine molecules, and on the dichlor, there are only 2. Real hard to get those names. Sorry. And dichlor, again, is not lost to sunlight because it has the cyanuric acid in it, which does stabilize it. Sodium hypochlorite, liquid chlorine. It's 10 to 15% available chlorine, high pH. It doesn't typically cloud the water unless your pH goes up too high. It does not increase your water hardness. It does not have any cyanuric acid in it. A lot of the times, if your customer has high CYA, I would typically tell them to use liquid chlorine, because that's not assisting in building up their cyanuric acid. It typically has a tendency to be less expensive than other sanitizers. As far as I know, there's not going to be a shortage of liquid chlorine this year. One negative to liquid chlorine is it does have a high total dissolved solids. 1 gallon of liquid chlorine has about 150 parts per million of total dissolved solids. So that does increase your total dissolved solids. Calcium hypochlorite, typically 60 to 65% active ingredient, 65% available chlorine, the higher pH. It can cloud the water. A lot of your calcium hypochlorite shocks will tell you to shock at night. One of the things I tell people, you should shock at night because it's 100% guaranteed to cloud your pool. And if you shock at night, then they will, by the time you get up in the morning, the cloudiness should be gone away. It is unstabilized. There is no cyanuric acid in it, so it is very good for commercial applications. And it is a class 3 oxidizer. And the boring molecules of those two products are below the pictures. Bromine tablets. Bromine is unstabilized. Benefit, it's unstabilized. Problem, it's unstabilized. You don't see a lot of bromine pools outside because once the temperature gets high, it burns off the bromine, so your pool is not sanitized. You see a lot of bromine spas and hot tubs, but not outdoor swimming pools. Bromine is very good sanitizer for indoor pools because you don't have the sunlight there that's going to burn it off. Has a pH of 4 to 4.5. It is an excellent algicide and bactericide. Bromine does regenerate. It's effective in a wider pH range. As I said, it's ideal for indoor pools and spas. 3 parts per million to 5 parts per million is your reading that you want to get, and it is tested with the DPD #1 test. There are 2 different forms of bromine. One is your BCDMH, which is a bromochloro. The bromine molecule has a chlorine molecule attached to it. And then there is a DBDMH, which is a dual bromo. There is no chlorine molecule on that at all. The only way I have seen the DBDMH is in a granular form. The BCDMH comes in a tablet or also in a granular form. Another EPA registered sanitizer that's not found in nature is biguanides, polyhexamethylene biguanides. And you can see it's a very long molecule. It just repeats itself. It is a non-hypochlorite EPA registered disinfectant. It's used in residential pools and spas. It is a program. It cannot be used in commercial pools and spas. It has a pH of 7.4. It's not affected by sunlight. It's not compatible at all with chlorine, copper algicides, or potassium monosulfate. The ideal range is 30 to 50 parts per million. And a common misconception is that PHMB causes pink slime or water mold. As I said, that is a misconception. If you have a dog water bowl, let it sit for a couple days. Don't let your dog drink it. You'll see tissue paper substance floating on the top of that pink slime or water mold. I hate to tell you this, but look at your shower heads. If you have a pink ring around the holes on your shower heads, that's pink slime or water mold. Pink slime and water mold grow in the water that are in the pipes for our source water. A lot of municipalities, majority of the municipalities are currently using phosphates, orthophosphonic acid, because it does cut down on pink slime and water mold. So you will see in a lot of areas high phosphate readings coming out of the tap. This is why. It's because they are using orthophosphonic acid to kill the water mold, which is not caused by the biguanide. It is in the water system. I've talked a lot about cyanuric acid, otherwise called stabilizer, or conditioner. It is, it's a weak bond. It forms a weak bond to the chlorine, which shields the molecule from dissipating or degenerating in the sunlight. It blocks the UV rays. The ideal range for swimming pools is 25 to 50 parts per million, depending on the health department in your area. Some health departments are saying 0 parts per million. That's very difficult to maintain. And it's very difficult to maintain a chlorine residual with 0 parts per million. Most of your salt generators are around 30 to 50 parts per million. So you do want to keep an eye on your cyanuric acid. You also want to know what your health department says if you deal with commercial pools. Low cyanuric acid can lead to chlorine dissipation. High cyanuric acid can increase your alkalinity. It reduces the effectiveness of the chlorine. That's why health departments want it lower. And it increases your kill time. Liquid chlorine has a faster kill time because it's not combined, but yet it's got a slower kill time because of the high pH. So it ends up equaling itself out. People, that it's considered, CYA is considered a carcinogen, and it can kill people. But if you dump 100 pounds of cyanuric acid on a rat, it is going to die. Cyanuric acid has been around for years, and we all know that there are issues that have come up in the pool industry over the last 20 years that weren't there 20 years before that. It is needed to keep chlorine in the pool, but we still don't want it to be at too high of a residual because it does cut down on the effectiveness of the chlorine. Some pool problems that we have: green algae. If you haven't seen green algae in a pool, you're very lucky. You haven't seen enough pools. Usually free floating. It has a mucus coating on the outside. If it is on the walls of your pool, it's why we tell you to brush, because you have to scrape off that mucus coating so that your algicide, your bactericide, or your sanitizer can kill it. There are over 7,000 species of green algae. People have asked me, why are there so many algicides? Well, why is there so many antibiotics? Because there's so many different viruses and there's so many different forms of algae. Solution to killing green algae: brush, make sure you get it off of the surface, shock, and use an algicide, a copper and or a quat algicide. One of the ways that I talk to people about brushing their pool if they have green algae is the green that you see is on the outside and it's dead. It's like your hair that's attached to your head, that's living. This out here, even though it can be pretty or ugly, it's dead. So you want to brush the algae to get it off of the walls so you can get to the living part of the algae to kill it. So it is important to keep brushing when you have algae in a pool. Blue-green algae, commonly known as black algae. There are over 2,000 species of black algae. It is a surface clinging algae. And again, it is protected by a sheath, a gelatinous sheath that goes over it. It does have the ability to penetrate plaster and vinyl surfaces. It roots itself in to the surface of the pool. So again, solution, brushing. You really need to brush this to get it off. Chlorine shock and a copper or a silver-based algicide. Your polyquats and your quaternary ammonium algicides are not going to kill this. There is a difference between black algae and liner mold. Liner mold grows underneath the liner and comes through the liner. Black algae is on top. With the liner mold, one of the best ways to tell if it is a mold coming from underneath or an algae on the top is look for a seam. If it's covering the seam, then it is an algae. If it's black and then you see the seam is the color of the liner and then black again, it's typically coming from underneath. The reason being, when they fold that liner over to make that seam, you've got multiple layers of vinyl and it's more difficult for the mold to grow through. And then we have yellow algae or mustard algae. Mustard algae is one of the most difficult algae to kill. It's commonly found on the shady side of the pool. It is resistant to a lot of your halogens and algicides. It can be transferred from pool to pool with your vac head, with your vac hose. So if you have service and you notice that 5 pools on your service have mustard, you may have carried that from one pool to the rest of them. Also, yellow algae or mustard algae can be transferred through the air. It can blow into a pool, and it can be brought in from on swimsuits and bathing suits. Solution, again, brush. I know customers get tired of hearing us say brush. Chlorine shock. Again, you're going to want to use a copper or a silver algicide. And flock. One of the reasons I say to flock is you want it to go down to the bottom of the pool. Flock will make it heavier. So when you vacuum to waste, you are picking that up instead of dusting it. You also want to clean the filter. After you have gotten rid of it, you definitely want to chemically clean your filter because there can be spores of this algae still growing in the filter itself. I have told people throw your toys in the pool if they've been in there while you're treating, because you want to kill it. It can be on those toys. Even when you take it out, you put those toys back in and you're reintroducing this product or this algae to the pool. As I said, it is one of the most difficult algae to kill because it can get in nooks and crannies where your sanitizer or your algicide aren't getting to kill it. Common cures, no matter what the issue is, check your filtration. If you have a cloudy pool, check your filtration. If you have algae, check your filtration. I went to a pool years ago that everything was perfectly balanced. The water was balanced. They had the right amount of sanitizer in their pool, but we could not clear this pool up. It was a sand filter. Took the multi-port off, stuck my hand down in there. I touched laterals. You should not be able to touch laterals in a sand filter. You should touch sand, and you should not be shoulder deep. What happens is water goes to the least restrictive area, and that sand pushes out. It also smooths down, so you can get channeling. That's what causes the water to just run through. I have also went to a pool, bumped a DE filter, and nothing came out. The consumer had poured all of their DE into the pool instead of charging their filter. And I've seen rips and tears in cartridge filters. So check the filtration. There could be something wrong with the filter itself. Check the water balance. That can cause cloudy pools very easily. To treat it, again, if all of those things are within range, superchlorinate, shock the pool, apply a water clarifier. Always read the directions on a clarifier. You do not want to overdose on a clarifier. There are clarifiers out there that if you overdose, then they will clear up the pool and then turn around and cause it to go cloudy again because it starts attacking itself. That's all I have. I want to open it up for any questions.
We do have a couple of questions. So the first one is, what causes black algae and why does it seem more rare?
Black algae can be brought in from pools, other pools. It can also be brought in from lakes and ponds. It's more rare in our area because of the temperature, the water temperature. In the south and southeast, they see a lot more black algae than we do, thankfully. So that's one of the reasons why we see less of it, is because of our air temperature. It can be brought in from other areas, and also just poor sanitization.
Is black algae different than single spore black algae?
There are, again, multiple forms of black algae. So we just, it's not really, sorry. I've moved over to 2 different screens now. What you just want to get in there and kill it. It is, I mean, it's just different forms of algae, of black algae, just like different forms of green algae.
Great, thank you. Can you expand on the term flock?
Okay, flock is, there are liquid flocks, and it is there's also granular flocks. Flock is an element that you put into the water that it brings the products, or brings what's in the water, causing it to be cloudy, together. It's also a heavy product. So with your system shut off, so your pool is not circulating, it will cause things to sink to the bottom of the pool. Years ago, a very common flock was alum. You would dissolve the alum in water and broadcast it across the top of the pool with everything shut down. It drops to the bottom of the pool, and then you vacuum it out. Depending on what kind of flock you use, Revive is a flock that is on the market. It has an attachment, so it attaches to the hose, and you spray it over the top of the pool with everything shut down. You let everything drop to the bottom of the pool, and then you vacuum it out. Alum-based flocks can remove phosphates, and then it can also remove metals from your pool.
Thank you. Back to the black algae. Do you recommend a treatment?
Yes. Brushing to get rid of the coating that's on the top of it. And a copper-based algicide works very well. I have a copper-based algicide that I love for black algae. And if you want to reach out to me afterwards, I can answer that. I really don't want to push my products while I'm on here. I don't think that's fair. But a copper-based algicide or a silver-based algicide, like I said, just using your quaternary-based algicides isn't going to work. But make sure that you're brushing. Did that kind of answer that question?
What are the benefits of either?
Coppers are easier to come by. Silvers are much more expensive. I prefer a copper-based algicide because that's what I sell. Silvers do work well, but as I said, they are typically more expensive and harder to find. Either one of them will kill as long as it can get to the algae itself. I prefer the copper.
Does that affect the chemistry?
Not typically. You will get a copper reading on your water test, but that copper should be sequestered so that it does not cause staining. That's why you want a good copper-based algicide because it is sequestered or chelated. Chelation is, it wraps the copper up to keep it from staining. There are multiple algicides out there that are chelated or sequestered to keep them from staining, and that's what you want. If you do get a copper reading on your customers, always ask them if they're using a copper-based algicide, because if they are and you're having them use a metal remover, then they're dumping in a copper-based algicide and you're taking it out. So, but that's the only issue that you would have with affecting the water chemistry is that you will get a metal reading.
Perfect, thank you. Should I expect water to be in balance during the winter/off season?
You should start the season with the water in balance. Start the off season with the water balanced. The reason you want to do that is it's going to cut down on, any liner wrinkling or anything like that. If you close a pool with water unbalanced, it's going to remain unbalanced throughout the season. When you close a pool, you're going to get outdoor water or, water coming in that is going to be out of balance. So, if you open that pool, don't be surprised if it's not balanced when you open it, but you want to give it the best water you can when you're closing it. So that's why you want to balance it before you close it. You don't know what the pH of the snow is, of the rain, and you don't know what's coming in that rain. You can have acidic rain. You can have rainwater or snow that has phosphates in it because being close to a golf course, and they use that as fertilizer to make the greens real pretty. You can get metals in the rains. I've seen metal in rains around the Philadelphia market, up in Allentown, over in Pittsburgh. I've seen a lot of metal in rains. And snow, you're going to get the same thing that you're getting in rains. So your water balance at the beginning of the off season, when you close your pools, should be balanced to give you a better chance to have balanced water when you open. Don't be surprised if you don't.
Okay, the next one says LSI wasn't mentioned. Was that on purpose, or maybe she missed it?
No, I didn't mention the Langmuir saturation index. The Langmuir saturation index is very important. It is also, I didn't want to go into to how to get the results and how to calculate the Langmuir saturation index. One of the issues, a lot of us have programs on computers that do our water balance for us, and they automatically give us an LSI. Issue with that is that if you're not putting in the correct water temperature, you're not getting the correct Langmuir saturation index reading. It is important because some things can be out of range, but your pool can still be good and not scaling. So it is important, but as I said, too many times people don't go in and adjust that temperature. So you're not getting a true LSI anyway. I hope that answers your question. To figure it out, in the time constraints that we had, I didn't think was worth going into. When if you've got it on your computer, then it's going to go ahead and give it to you. If you do have it on your computer, always adjust your water temperature. When you open your pools, you don't have 80-degree water. When you close your pools, hopefully you don't have 80-degree water. I tell people 60 and 60. You open the pool before the water hits 60, and you don't close your pool until the water hits 60. Reason is nothing's growing at 60-degree water. So you have a better chance of opening an algae-free pool if you do it within those time within that parameter of 60 and 60. But always try and adjust your temperature, or you're not going to get a correct LSI reading, no matter what lab you're using, or if you're figuring it out manually.
Great, thank you. The last question that we have right now is, I've heard you can get pink algae from the ocean. Is this true, and how do you get rid of it?
Yes, it's true. You can get it from the ocean. You can get it from the source water. It can travel from pool to pool on swimsuits, on toys. How do you get rid of it? Again, brush if it's outside of the pool. The reason you want to brush is pink slime or water mold, again, has a gelatin-like coating over the top of it. If you can lift that coating, then your sanitizer will kill it immediately. I've been told in the past, we don't get it in chlorine pools. Yes, you do. You just bleach it out. And that's why it became water mold instead of pink slime, because it's bleached out and you don't see it as bad. If it's in the line, then your best way that I have found is you want to run a high concentration of your sanitizer through the lines. And your problem with that is if you're using, you've got to pay attention to the pH of the product that you're using to run through the lines, because it can have effect on your heater, your pump, your gaskets, and everything. I know the biguanide systems used to use potassium monopersulfate, and they would have you pour potassium monopersulfate or a non-chlorine shock through the lines, and that would irritate that gel coating enough to get it up so that the sanitizer could get in to kill it. I've done that. On a chlorine pool, I've also run bromine, granular bromine through the lines, put it in a stocking, put it in the skimmer, and let it run through. And what that does is it puts something different in there that pink slime has not grown accustomed to, or to where it's able to break it up, lift it up so that your chlorine can get under there and kill it. Those are the best two ways that I have found that work. Superchlorinating can help cut down on it. The municipalities are using phosphates. The problem there is, then we have an issue with, high phosphates, which can lead to cloudy water and lead to other, issues with the chlorine. So the non-chlorine shock and the bromine are the best things that I have found.
Perfect. I know we've reached time, but we have 2 more questions if you don't mind, if you want to take them or...
Yeah, I don't mind.
Okay. So the first one is, do you need to warn prior swimmers to wash all suits and toys so they do not redeposit?
Yes. My kids, when they were little, my babysitter had a swimming pool, and she had the kids, they had to leave their swimsuits at her house. They were allowed to swim in her pool if they left their swimsuit, because that way she knew what was getting into it. I love that. You know, I have a pool in my backyard. My boys have friends over that go swimming, and no, I don't make them wash their suits when they come over. Um, but should I? Yes, it's going to cut down on issues. But these kids don't have pools at home. Um, so that's, you know, it is a good idea. I don't allow other people's toys in my pool. If somebody does bring over something, I would definitely wash it off before they put it in the pool. Spray it off.
Okay. Next is, can you use a calcium-based shock if hardness levels are low enough?
Yes, you can. I used to do that all the time. I would tell people, and I still do, you know, you need to shock, your calcium's low, let's save you some money, and shock with a cal hypo. If somebody's pH was low, I've had them shock with liquid, because you're going to bring your pH up at the same time that you're shocking.
Follow-up to that is, even in salt pools?
Follow the recommendation on your generator. Sorry to say that, but different generators say yes, you can, and some say no, you can't. Some say to shock with liquid, some say don't use liquid. So I always just tell people, follow the directions on your generator. Have I? Yes, but the generator said you could.
Okay, and we do have one final question. Do you like salt pools?
Oh, that's a toughie, because if I tell you the truth, no, I don't. I don't like salt pools because the consumer has a misconception. They have been told you don't have to add anything to your pool. So they don't think that they have to adjust their water chemistry. And then when you tell them that you have to watch your pH and your alkalinity, well, you're lying, or the person who sold me the pool is lying. And, you know, like I said, they have a high pH, which is not maintained a lot. And I think that there are other issues that the consumers have been told, you know, you don't have to do anything else. If it is properly maintained, I don't have an issue with a salt pool. You know, I work with people with salt pools. Do I like them myself? No, because I feel like it's been misled to the consumer. I've been told, oh, I don't swim in a chlorine pool, I swim in a salt pool. Wrong. You're making liquid chlorine.
Okay.
So, if anybody has any questions, feel free to reach out to me, or, you know, anybody. But if you want, you can reach out to me. I have, there was a gentleman that I worked with for 10 years before I ever met him. We talked on the phone on a regular basis if he ran into a pool problem. And about 3 years ago, I met him at the Southeast Pool and Spa Show in Nashville. And it was the first time we had met, and we had been talking for 10 years. So, you know, I can help you out. I may not be able to fix everything. I do know other people I can go to for answers.
Perfect. Thank you so much, Rebecca.
Uh-huh.
To answer one of the questions, this will be recorded. This is recorded, and will be available to the attendees and registrants. Oh, look, final question. Okay, I know it's already 7:05, but what do you use in your pool?
I use Pristine Blue. Pristine Blue is a copper-based system. It is an EPA registered bactericide and algicide, and that's the system I use.
Great. Would you, so someone is asking if you would send your contact information. Would you be all right if I include that?
Oh, yes, please do.
Okay, perfect. Okay, so I will include Rebecca's contact information in the follow-up email with your certificate of attendance. So you should have that within the next few days. I would like to thank everyone for attending, and I want to thank Rebecca again for taking the time and doing this virtual water chemistry class. And we do have a bunch of thank yous and saying it's very informative.
Thank you. I hope I didn't bore anybody. I know I get a little geeky at times. And believe it or not, I got a C in college chemistry.
Oh, well, I failed college chemistry, so it's very interesting and very, very good, everyone's saying. So thank you, everyone. A survey will pop up as soon as you close your Zoom window, and it will be sent in a follow-up email tomorrow as well. We always appreciate your feedback. And if there's no final comments or questions, or if there's anything else you want to share, Rebecca, I guess we could call it a night.
Thank you, everyone.
Okay. Thank you so much.
Happy
Bye.
holidays.